All right, thank you so much for joining us tonight. Good evening, everyone, and welcome to our Superstellar Friday for August. We are so excited to welcome Francis Tarasiewicz from the Mount Washington Observatory to join us for this special presentation. Francis is an Education Observer and Meteorologist for the Mount Washington Observatory. This is his off week, so he's off the mountain this week, back up there next week to have all fun with that beautiful weather that they have up there. He's going to talk about some of his work that they do up on the observatory, as well as some of the crazy weather that Mount Washington gets and why they have it. So without further ado, I'm going to hand it over to Francis, and I hope you all enjoy the presentation.
As she mentioned, my name is Francis Tarasiewicz, and I spend a lot of time in some pretty extreme weather. But just by a show of hands, I want to see who here has actually been up onto the summit of Mount Washington. All right, wow, that's like the majority. Usually I get like a quarter to half of them lucky. So of those folks who raised their hands, do you remember the wind speed when you were up there by chance? You can just yell at the, sir.
148.5.
Really? Okay. Anyone else have anything close to that? 50 is even impressive. 40. Well, that's pretty good. That's tropical storm force. 40? Yeah, it's pretty good. Generally, folks visit up in the summertime. That's when we have our lower winds. But if you did come up, you likely had a very similar view to this. So this is actually our live deck cam right here on the summit of Mount Washington. You can see the night observer doing her thing out there. But this is essentially my office. And you give an update there. Down below this part of the weather deck, you actually be in our office quarters where we do a lot of our forecasting. So again, show of hands, has anyone actually been inside the observatory itself and got to meet the weather observers? A couple people. Okay, that's still pretty good. It's better than what most times. But yeah, this can be found on our website, mountwashington.org/webcams. So, you know, if you have a snowstorm or nor'easter down here, I can guarantee the site on this is going to be even more entertaining watching the weather observers try to take their observations in those extreme conditions. We've also got new webcams facing to the north, whereas this is a northeast towards the Carter-Moriah Range. I also do want to talk about some of the current conditions up here on the summit at the moment. Is anyone familiar with this site? Yeah, a couple of hits, cool. Yeah, so this is another really cool site to look at. This is currently what's going on the summit. In visibility, the last hour was around 30 miles, and unfortunately for you guys, down to about 1/8 of a mile. But we spend about 60% of the year on the summit in the fog. You can see the temperature now. As you go up the Otter Road, we have a mesonet of weather stations going from 1,600 feet at the base all the way up to 6,288 feet. So if you ever drive the Otter Road and kind of make that white knuckle drive up, if you look on the sides, about every 1,000 feet or so, you may notice a weather station. So again, we go from about 77 degrees at the base down to 60 degrees on the summit, so about a 13-degree difference. That's tame compared to what it could be in the wintertime. Sometimes the difference is greater than 20 degrees on those coldest days. But yeah. In terms of wind, not a very impressive day. We're under sort of transient high pressure right now. We've got about 10 miles per hour. Of course, it can get much worse and much more intense. Over the last 24 hours, we've seen a gust of 48 miles per hour. So a tropical storm force there. And that was around midnight or so. So things have calmed down quite a bit. Yeah, relative humidity is creeping up as well. So they're about to be socked in the fog. And as I mentioned, that's definitely not an uncommon occurrence. We spend about 60% of the year in the fog. Does anyone have any questions about these 2 pages before I continue with the main part of the presentation?
Can everyone hear everything okay? Maybe a little bit harder in the back.
A little harder in the back. All right, use my diaphragm a little bit more. So yeah.
So the microphone is actually recording for our recording for this evening.
Yeah, I will step out from the safety of the podium here a little bit, if you'd like. How about that? So tonight, I want to talk about my home away from home, the home of the world's worst weather, on the summit of Mount Washington. But to do so, I want to just introduce exactly what Mount Washington is. So a lot of folks think that we work for the government, but we're actually a private nonprofit organization, and our goal is to advance the understanding of Earth's weather and climate. And so if there's an observer there, another part of my office, they're likely de-icing, as this is midwinter. They're probably adjusting one of our anemometers on the top, one of the instruments that's measuring the wind. But this is not an uncommon scene in the wintertime to have cloud cover below the summit. We call those tops lower. And we're one of the only weather observation sites in the United States that can report clouds below the summit. So this is a pretty ideal winter day. Of course, it can be a lot foggier on any given day. So I want to talk a little bit now about the history of the summit of Mount Washington. And so when thinking about the history, we have to go back to indigenous folks, all the way back to the Abenaki of northern New England. They were some of our first weather observers. They revered the summit of Mount Washington as a very sacred place. They had many names for it, which you know, have been proven true. Hidden mountain always in the clouds. Yep, can definitely say that. Mother of the great spirit, or mother goddess of the storm, could definitely agree with that as well. So they were already sort of making observations about the summit, even in prehistory. So just so we definitely want to recognize their contributions. The first actual ascent by a European was made by Darby Field in 1642. He was born in Ireland, lived in Durham, New Hampshire, and he traveled via the Saco River. So quite a long journey there on foot, and he was accompanied by two Native American guides. The first sort of year-long expedition on the summit, where people actually lived on the summit, took place much later, 1870 to 1871. You had the Huntington-Hitchcock expedition. And that building, for some of you folks, might look a little bit familiar there on the left-hand side. That's the stage office nowadays, but that's where the original observers spent their time. They spent a full winter up there to get a sense of the conditions. Of course, they were convinced to come back after about a couple of years of break there. And the next group was the U.S. Signal Service, and they actually predate the National Weather Service. So this was before them, under the Department of Commerce, which needed observations to expand the weather observation network across the United States. So you can see there, again, a nice little cozy building, a far cry from what we have today with the Sherman Adams building. But this was the first time that observations were taken for operational purposes, and in this case, helping with mail and weather forecasting as well. So we had to zoom now all the way to 1934, but we had a really great team to establish the actual observatory. This was the polar year, so there was great interest in what was going on at Earth's poles and the Arctic regions, sort of exploring the weather and how that relates to the Earth's weather and climate system. So you had several folks coming together all at once to make sure that the observatory was founded on good footing. You had Joe Dodge, who worked with the Appalachian Mountain Club, the AMC. You had Bob Monahan, who was a master's student of forestry at Yale University under the umbrella of the New Hampshire Academy of Science. And of course, you had some external talent as well to help get this going. So you had Elliot Libby, formerly the Carriage Road owner, now the Auto Road. Colonel Henry Teague was the owner of the Cog Railway. Dr. Charles Brooks, the Blue Hill Observatories down in Massachusetts. They were one of the first long-term observatories in the United States, so they're still doing their thing down there at a lower elevation, admittedly, but still their work is quite important as well. Then you had Henry Shaw, who worked with General Radio Company, so you needed, obviously, communications from this newly formed observatory. So these were sort of the managerial staff, I guess you could think of, but these were the actual first 4 observers on the summit. So again, I just love how humble that original building was. And that'll be more important, as you'll see in a couple of slides. So you had 4 very brave people, admittedly. You know, nowadays with the observatory, we complain when the Wi-Fi goes down, but they definitely had a lot more of a struggle back then. You had Alex McKenzie, who was a radio expert, Bob Monahan, of course, expert in mountaineering and forestry, Joe Dodge as well with AMC, and then Sal Paluca, another radio expert and person who was more of an expert with meteorology as well. Of course, within a couple of years, the Mount Washington Observatory recorded the strongest wind ever recorded by a staffed weather observatory. This occurred on April 12th, 1934. You can see the observer there holding the original anemometer that actually took that reading. And on the right-hand side here, this might be a little bit confusing, but it's a old weather map on that particular day. So what made this day unusual was that we had an area of low pressure to the south and a broad area of high pressure to the north. And that resulted in a really strong difference in pressure. And so winds tend to flow from low to high pressure. And the stronger that difference is, the stronger the gradient is, the faster the winds are. So on this particular day, the observers got up. They were hearing noises they hadn't heard before in their 2 years up on the summit. But their anemometer was, quote, only reading 150 miles per hour. So one of them, literally climbed this ladder, got up and de-iced the anemometer by hand with a small wooden club. You can actually find this anemometer in our museum on the summit. It won't really move or anything like that, but it's just a really cool piece of American history. But this reading here of 231 started off again 150. As soon as they de-iced it, it shot up to 220 miles per hour, peaking around 1:12 in the afternoon at 231 miles per hour. And of course, the observers, being scientists, didn't believe it at first. So they actually, the interesting thing about this anemometer is it was attached to a telegraph wire, and the rate of clicking related to the wind speed. And so they independently sent that signal to the Blue Hill Observatory as well as MIT. So it was verified by 3 different organizations. So pretty incredible stuff there. And again, it still lives in our museum. The other record, which is the next question I get, was set back in 1996 with a cyclone off the coast of Australia. That was 254 miles per hour. So they got us beat. But that was a unmanned, there was no people actually taking that reading. It was an instrument there. So a little bit about our extreme wind. So the weather station has changed quite a bit over time. Initially owned by Dartmouth, with the stage office between 1932 and 1937. A lot of the wood you see there was actually given to us by the Cog Railway, so they've always been a great partner of ours. They helped us actually last year when part of the auto road washed out and we had a late season blizzard. I don't know if anyone remembers seeing that in the news at all. That was definitely a heck of a shift change there. We have the old house between 1937 and 1980. A bit more of a fortress there, maybe a bit more apt to staying on the summit. And then the Sherman Adams building from 1980 to the present. And a little bit about the Sherman Adams building. A lot of people ask if it's safe to be in those conditions. Currently, it's rated for 300-mile-per-hour winds. It ranges between 3 and 5 feet thick, fully reinforced concrete as well. So the only times I'm afraid to be in that building is when it's colder than 0 degrees and the metal starts to creak and expand or contract at the same time. So you get a lot of loud popping noises. You'll be doing your work and all of a sudden you hear a crack and you just sort of shoot up out of what you're doing. So it can definitely give you a fright there once in a while. But yeah, if you're visiting us these days, it'll be the Sherman Adams building. So it's a lot about the history of the summit. Yes, you have a question in the back.
What are the buildings? Did they ever go down in the wind?
They did not actually, amazingly. So someone was talking to me about the engineering of these buildings the other day. They literally have like segments of wood like doubly glued together because they do have a replica of that building, which is actually currently the Auto Roads gift shop on the summit. So yeah, they've never really blown away. More likely, some of them did unfortunately burn down throughout different periods of history on the summit. So of course, we weren't the only entity up there, but yeah, good question. And yeah, as I'm going forward, if anyone has questions, yes, sir.
Yeah, on that day when we had the world record and it peaked at 231, I think it was. What was the sustained wind speed for like half an hour, hour or more?
Yeah, really good question. So up into the 150-mile-per-hour mark.
Wow.
And we tend to get our gustiest winds from southerly directions because compared to the Northwest is nice and open. I'll show you folks a topographic map in just a little bit, but the Southwest is a lot more channeling, a lot more valleys and mountains for the wind to actually go up and over. So we get these gusts and lulls in the wind, which we'll talk about in a little bit. Yeah.
So it was going 150 miles an hour for like an hour's time.
Oh yeah, definitely. Category 5 hurricane, basically.
That's amazing.
And it wasn't, again, the cool thing with that was like it wasn't associated with a tornado or a hurricane or really any kind of severe weather. It was just more or less a run-of-the-mill nor'easter style storm, which was pretty cool. But talking a little bit about our normals and means here, extremes as well. Our average annual wind speed is 35 miles per hour. So of course, the lowest of that occurring during the summertime. Annual temperature, 28 degrees. The warmest is around 50 degrees on average for a monthly average occurring this month and next month. Average snowfall is 281 inches or so. Liquid precipitation, if you melt down all the snow and you account for all the rain that falls, 91 inches of liquid. And as I mentioned, yeah, 60% of the year, we have a view very similar to what I showed you folks a little earlier with that fog. So it can get a little old sometimes. Thankfully, we have Nimbus the cat, so he helps things along.
Concord about 60 inches.
What was that?
60 inches of snow a year in Concord, something like that.
Yeah, definitely an interesting comparison. We had 60 inches in a week last January, so not to brag. So again, we'll talk about some of the extremes now. The maximum sustained or wind gusts there, 231 miles per hour. Again, April 1934. Maximum air temperature. This one's interesting. It's only ever really got up to 72 degrees. Back in 1975 and 2003. This last summer, we had that heat dome overhead, that really crazy heat wave. We got up to about 70 degrees. So we were watching that thermometer very closely. This record we'll talk about. We've got a couple of slides all about that. But again, January 1934 and then February 2023. Just imagine myself, I was there for only 6 months, and then a new intern. He was there for about 2.5 weeks. And so the two of us recorded that. And I'll talk all about it in a couple of slides here. Maximum seasonal snowfall, 566 inches, basically 60 feet of snow. The winter of 1968 through 1969, 100 of those inches actually fell with a single snowstorm, which lasted 72 hours, affected a lot of northern New England. It was called the Lindsay storm. But again, of course, that year also had the maximum liquid equivalent of moisture, 130 inches of just rain and accumulated precipitation falling from the sky. All right, we're ready. We're going to talk about now that extreme day on the summit. So if we all think back, February 3rd to 4th, 2023, we had an exceptionally mild January on the summit and in the whole region as well. The summit recorded an air temperature anomaly above average of 10 degrees Fahrenheit. So it was a very warm January. We really didn't see this coming. But high in the Canadian Arctic, right near the Arctic Circle or so, in an area of the polar vortex, which is just an area of low pressure that exists right near the stratosphere, it was knocked loose. It was knocked further south towards the mid-latitudes where we live. And so we had a quick but brutal 2-day stretch of cold air accompanying this feature. Maybe some of you folks unfortunately had pipes burst during this, or I'm sure folks will kind of remember where they were during this. But you can see on this map, this was the forecasted air temperature at the summit of Mount Washington just a couple of days before the event. And you can see the cold went off the scale. It was showing 61 degrees below 0 Celsius there. Mount Washington, of course, being right up there. So what was it like on the summit? Well, it was a tough day at the office, we'll say. I've got a quick video here for you folks. Hopefully this works. So yeah, this was during our peak wind, and our peak wind gust was around 127 miles per hour. And yeah, this was Carl, my coworker now. He was an intern at the time, but he decided to go out and get a quick video during the peak winds. So we had temperatures at or below 45 degrees below 0 for 13 straight hours. We expected a really cold burst of air and then for it to quickly recover. But instead, we got a nice plateau right around that really cold temperature.
I hope you're really well paid to be up there doing that.
Oh, yeah. So the 47 degree below 0 rounding, it's the coldest in 89 years in our, tying our record low, of course. We had wind chills below 100 degrees below 0 for 15 and a half straight hours. And we had 109 below as the official sort of lowest wind chill during the event. And then, yeah, sustained winds over 82 miles per hour for 28 hours. And that peak wind gust of 127. During all of this, about 0 hours of sleep. Maintain this record because, of course, when you get close to a record on Mount Washington, you're taking those temperature readings more frequently, perhaps every 10 minutes or so. And so this was no exception. So yeah, we officially tied it here. This is the form we actually send to the National Weather Service, our V16. You can see there, 47 below. And that was my team and I right after it. 3 people. We ran the whole thing. Of course, folks in the valley definitely helped us, but yeah, average wind chill during the time was about 107 below. So that was an incredible day, something I won't forget. Yeah, a lot of folks ask if we're really the home of the world's worst weather, and so I'm going to talk a little bit about what makes, yes?
I was just gonna ask, was that the coldest recorded temperature on Earth?
It was not. So it was a very cold wind chill, and there's some debate as to whether or not it actually broke the wind chill record for North America, but definitely more research needs to be done on that. Yeah, great question. So a lot of folks ask, are we really the home of the world's worst weather? And there's maybe some other mountains other than Mount Washington that have slightly worse weather, but observations do not seem to have been made upon them. That's what Charles Brooks said, the director of the Blue Hill Observatory that I mentioned a little earlier. And what makes our weather very extreme, as we'll say, is the addition of moisture, right? Antarctica, it's very cold, but a lot of time you have high pressure. Antarctica is basically a desert. Whereas, you know, Mount Washington being at the top of New England, which already has some pretty crummy weather at times, or depending on how you look at it, you're really exposed to a lot of different factors that create extreme weather. So these are the 3 main factors. Of course, there's a few more we could talk about, but the topography or the shape of the terrain in the Mount Washington area, something called the Venturi effect, which we'll definitely talk about, and then the frequency of storms. So what this image is showing you here is rime ice. And so rime ice is super cooled water that's below 32 degrees. It freezes into the wind in these beautiful feathery shapes. When it's cold enough, when it's right around 32 degrees, we get this glaze ice, which is super thick. And I'll show you folks a picture of that towards the end of the presentation. Getting back to why the weather up here on the summit is so extreme, a lot of it has to do with the prevailing winds. So looking across the United States, especially the eastern part of the United States, looking to our west, the tallest mountain is Hardy Peak in South Dakota at 7,242 feet. So what that means is there's not a whole lot to actually slow these winds down as they make their way across the country, except when you get to the White Mountains. Of course, you have the Green Mountains, but the highest elevation there is only in the low 4,000 foot range or so. We don't get a lot of winds from the southwest. We got Mount Mitchell though, which would potentially help slow down some of the winds. But again, we're really exposed here on the eastern United States. Additionally, once you zoom in a little bit closer to the White Mountain range, you notice a bit of a triangular shape to the actual mountain range itself. So it acts like a bit of a funnel, or putting your thumb on a garden hose, if you will, as those winds enter. And our prevailing winds, again, come from the west or northwest. But we do record 100+ mile per hour winds from any direction. And so during the wintertime, our cold season, we'll have 100+ mile per hour winds every 4 days or so on average. It doesn't necessarily work like a clock, but generally speaking, when you average everything out, again, 100+ mile per hour winds every 4 days, but 74 mile per hour winds or greater hurricane force every other day. So pretty cool stuff there. So again, the terrain plays a large role in it. I mentioned the Venturi effect. So again, there's a metaphor with the thumb over the garden hose. So during the wintertime, the troposphere, the level of the atmosphere that we live in, tends to expand and contract. So in the summertime, it expands a little bit because it's warmer, but in the winter, it will contract. The air is a bit more dense, it's colder. So that tropopause, the top of the troposphere, will come down in elevation quite significantly. Sometimes it's just over the top of Mount Washington. So the importance of that tropopause layer is that it acts like a lid on the winds. The winds really can't mix above it because the air is much more stable. It tends to warm with height in the stratosphere. And so the winds can't go through Mount Washington. Instead, they go up and over and are enhanced by that tropopause and squeezed once again. So we've got horizontal and vertical squeezing of winds to speed them up. So you might have a question?
Yeah, I gotta ask this.
Yeah.
So those days when the wind is 100, 130, 150 or more miles an hour,
Yeah.
you probably still have to go out and de-ice the instruments.
We do, yeah, and we'll talk
So
about.
when you do that, are you somehow attacked so you just don't get, I can see you getting blown like over the side?
So what I'll show you is we have a lot of piping and things like that. We've tried ropes, but they get iced over and they become a hazard in their own right. A lot of it is just communicating with the team, making sure we have 2 or 3 people going out there at once. Yeah.
It would be very easy, like to.
I'll show you. It's a little bit harder than you might think, but yeah, I appreciate your concern, definitely. Yeah, does this Venturi effect kind of make sense to everyone? Yeah. Any questions with that? Great. I mentioned too the frequency of storms. So we've got a weather map here, and of course the Mark Twain. What was it?
All the storm tracks.
Yes. They seem to kind of converge. Yeah, so Mount Washington, if you folks can't see it clearly, a little white star there. And in the words of Mark Twain, if you don't like the weather, New England, wait 5 minutes. So these storms are constantly coming and going along the jet stream, which is moving from west to east. And so for more frequent storm tracks here, you may recognize this one. This is a nor'easter. And so the winds will flow around that from the northeast. It'd give us a lot of snow with all that moisture coming off the ocean. So again, with the frequency of storms, they're passing through about every 4 days or so during the cold months, so the fall and winter. Yeah, those sort of come together to give us our extreme weather. So we've come quite a long way.
I have a question again regarding wind speed. On the record-breaking 231, what direction was that wind coming from?
Yeah, good question. So that was southeast.
South?
Yep.
So it was following one of those tracks then?
It was, yeah. The storm was likely going to our west. And so when you have that, you have a counterclockwise flow around it. So yeah, that would have driven that southeasterly wind direction. I remodeled that storm, and you had southeasterly winds all the way up through the top of the troposphere. So it was a very deep layer of southeasterly winds. That probably helped make that event so extreme. But yeah, we'll take a little bit of a break from talking about the weather specifically. We'll talk about what exactly we're doing on the summit. That's a pretty popular question that I get. A lot of our work is divided into 1 of 3 categories. We've got weather operations, which include the observations and the forecast. We do educational programs similar to like what we folks are perhaps hopefully enjoying tonight. And then research and product testing. So we have a lot of folks that pay us to take their products up to the summit and hopefully be as nice as we can to them in those crazy winds. But yeah, what are weather operations? These are 24/7, 365. We've got our night observer there in the upper left-hand side. We issue our higher summits forecast twice a day. Has anyone here ever used our higher summits forecast? So maybe, yeah, great. A couple hikers, and great. But yeah, we are staffed by 2 shifts of 3 observers each on each shift. So we get 8 days on the summit and then 6 days off. So I'm on my 2nd day here. But what is captured in a weather observation? This is sort of the code we use. This is METAR code. It's what pilots use to determine what the weather's doing and where they're landing and taking off. But I'll translate all this for you folks. We've got wind speed and direction, visibility, the present weather, what's falling out of the sky basically, or is there dust, things like that. Cloud cover and cloud heights are really important for pilots, knowing that ceiling, temperature, as well as the dew point, how much moisture is in the air pressure, precipitation, and of course there's even more with some of the observations. But how do we determine these different factors? We've got a lot of different thermometers on the summit. So one here, we've got it in a nice sort of lightly painted, we call it thermostat, to prevent solar radiation from being absorbed. This is how we determine our climate records. We've got our 6-hour maximum, or 6-hour minimum and 6-hour maximum thermometers. And that's where we're able to maintain climate records. going on 91 years now on the summit. This observer has what's called a sling psychrometer. It's a big word, but basically it's a device to measure moisture in the air. And so we measure these things each hour on the about 45 past the hour. We've also got a wide, yes.
Are your instruments mostly analog or digital instruments?
We do have digital instruments, but the ones for the observations that we send to the Weather Service, we try to keep them analog to sort of maintain the history of our observations. Sling psychrometers date back hundreds of years, but basically what you're doing is you have a thermometer that's wet and one that's dry, and as you spin them, the wet one will evaporate and cool. And so that cooling is actually related to how much moisture is in the air. Similar to if you step out of the pool and feel cold. So that's what that technology is there. The fun thing about sling psychrometers is that on a good day, it's foggy, so you don't even have to go out. The air is 100% saturated. We're in a cloud. But of course, there's days where you're spinning them for 15 minutes at a time because the air is so darn dry. Those are usually the days where it's, 20 below. They talk about tennis elbow, but I feel like you can get sling elbow as well. I don't know if that's a thing, but yeah. We'll talk a little bit now about anemometers. So most of you folks are, people here who are interested in weather, you may recognize this one. This is a propeller-driven anemometer. The faster the winds go, the quicker that propeller spins. It's pretty simple. During the winter time, we get all that rime ice, and it gets really cold, so the plastic gets brittle. So we're not able to really use those too much in the winter time. So instead, we turn to aviation to actually keep our data set going. These are pitot tubes. So typically, you find them in aircraft, and those are recording the forward speed of the aircraft. But we've modified them slightly to actually record wind speeds on the summit of Mount Washington. So what these have are some holes on the side and then a big hole in the front. So that difference between the static pressure that's being recorded on the side and the ram force of the wind on the front gives us a wind speed. So yeah, it goes down a tube, and that tube basically pulls a diaphragm, which results in an accurate wind speed. So again, the cool thing about these is that we're able to keep them nice and heated, even during the strongest storms. We'll keep them up to about 300 degrees or so. So definitely don't want to touch them at all, which I've definitely burned my jackets a few times trying to adjust them. But these sort of balance each other out, right? So when it's icing, we're using the pitot tubes. But when it's nice and clear and the winds are light, we'll use the RM Young anemometer, the propeller-driven one. You can turn in a lot lighter winds. So they definitely complement each other. We have a lot of data. So how do we visualize it? We've got different ways. We've got, of course, the standard line graph there, which hopefully looks familiar. Of course, the higher up on the graph here, the stronger the winds. This is measuring about 100-knot winds, or somewhere in the mid-100-mile-per-hour speed. The normal people do actually just use miles per hour instead of knots. But this is our haze chart. This is what makes the observatory a bit more unique. So this is a piece of paper we change out each day, and what it does is it slowly rotates in its housing. And it's got a pen sort of from the middle to the side there, and the stronger the winds are, the more that pen is actually pushed out. So we're looking at a haze chart here from February of 2019. This is the strongest wind speed day of the 2010s, 171 miles per hour. So you can see the winds literally went off the chart there a few times on the haze chart. And you had sustained winds over 100 miles per hour for 48 hours. So just another couple of days on the summit. But a pretty unique day there. A unique way to visualize changes in wind speed as well as wind gusts. Any questions about how we record wind? Yes.
So on that graph,
Yep.
when it goes off the chart, so to speak, is there another instrument that picks up where that one leaves off, so to speak?
Yeah, so someone had previously asked about digital instruments. So we do have digital charts and ways to record, but we also do have another haze chart called the Barton chart. And it looks a lot less exciting because its range is up to like 300 miles per hour or so. So when this chart starts to get maxed out, you'll see a little blip appear on that one. And that's when we know it's a very impressive event. But yes, of course, we do have the digital readout as well. So yeah, good question. All right. We'll talk a little bit about barometers as well. So of course, we're measuring air pressure on the summit, as air pressure is closely related to wind speed. So you'll see there on the left, that is our precision digital barometer, PDB1. I always struggle to say that for some reason. It's a bit of a mouthful. But you'll find these at every weather station in the United States. What I want to point out to you folks here is that top number. It's in millibars, which is a unit of pressure. It's about 200 millibars lower than what you see at the surface. Because we have about 20% less force pushing down on us on the summit of Mount Washington. And it's only 6,000 feet in the air. I mean, to go through 20% of the force of the atmosphere is impressive. And it shows you how fragile and small our atmosphere really is. on the grand scheme of things. That's the most modern tool. We'll go back in time now with our tools. We've got our barograph, which is measuring measuring air pressure over the course of 4 days. So you can see on this particular day, it was quite low. It's below 22 inches of mercury, which any weather observers out there will know that's fairly low. We usually are around 24 inches of mercury. And then we've got like the grandfather, I guess you could say here, on the left-hand side. That's the barometer that the Blue Hill Observatory donated to us to get our start. They, of course, kept the first oldest one operational in North America. So it was a nice present, but they kept the coolest one, which is totally fair. Precipitation. This is a bit of a pain to measure on the summit. We measure it every 6 hours as it falls. So we have here this what's called a Knifer screen. And this is designed to keep the majority of the influences of blowing wind away from the actual precipitation measurements. A lot of people think, of course, Mount Washington, we get a lot of snow, but which is the case, but it actually doesn't stick around for too long. It's usually blowing right off the summit. And so what this is designed to do is to sort of minimize that blowing and drifting of the snow, at least around the immediate area of the precipitation can. So you can see this observer, we're holding 2 cans. They're actually of different sizes. So our winter one is a little bit, it's about 2 feet taller than the summer one, just because of to account for the extra snow. So I can explain that, but the best way to really talk about this is to show it and the actual process of getting those hourly observations of precipitation. So here's our night observer going out with a camera person, and yeah, we'll follow along through his adventures.
Blowing about 90 miles per hour, and only gusts up to 100. Albeit it's strong, but it's not too dangerous for myself. I've been out in these plenty of times. Now, right now we have a northwesterly wind, so we're kind of in the lee of the building, so it's not too bad. But once we get to the end here, we'll feel the fill.
Now, once it gets around this part of the building, you're going to get a funneling effect between the Sherman Adams building and the Tip-Top house. So you'll see how much stronger these winds are.
What's he carrying?
So that's his precipitation can. He's going to go replace it. Yeah, so. Well, that was pretty much, that was the gist of it. I just found that funny because he was very nonchalant about it. You know, only 100 miles per hour, only gusting of this or that. That particular observer has actually been working there for 20 years. So we've seen a little bit of everything. I think his maximum wind is about 171, whereas mine is 150, so I'm catching up to him. So we also, the reason we have people up there is just basically because anything that could automate the process of weather observations would be covered in ice. It could be broken within just a couple of months. And we've tried all sorts of automated instruments, but really nothing beats the human senses on the summit of Mount Washington. So with our eyes, we can determine visibility. We can determine sky conditions, what exactly types of clouds that are in the air, what height they're at, how much of the sky they're covering. Also good at verifying readings, probably my least favorite part of the job. So each day, a part of your shift is actually you looking back at your previous readings and pick out any mistakes that you or maybe your coworker makes. So it's either an awkward conversation or are you kicking yourself a little bit, just like, how did I not notice that cloud cover, or just whatever might come up in a day. But yeah, we're also useful in determining precipitation types. And the reason I picked this picture is we've got an interesting cloud type there that's called a lenticular cloud. And these types of clouds indicate strong turbulence or changes in wind speed and direction and height. And pilots, I would never recommend you flying into one of these because they're quite turbulent, quite dangerous, can feature very, very strong winds. And so we'll actually note those in our observations. Also, cumulus standing lenticular clouds, ACSLs. And so pilots will see that and know to steer clear of the White Mountains if we are reporting them. Someone had asked about de-icing. That's part of a lot of different types of maintenance that we have to do in the building. So we're shoveling snow, but we're also knocking the ice off of our instruments to keep them going, to keep the observations flowing. So I've got another couple of videos, and hopefully these cooperate with me as well. So this top one is an observer de-icing at 60-mile-per-hour winds. And then the bottom one will actually double that wind speed. It'll go to 120-mile-per-hour winds. But let's start off here at 60-mile-per-hour winds. It's a moderate tropical storm. And we'll get some sound. A couple things you may notice: the camera person's trying their best to stand upwind of some of the flying ice. And of course, they're using the vibration of sort of striking the tower there to get the ice off. They're not actually hammering the instruments themselves. To the gentleman's point earlier about being safe up there, so we've got that ring. We've also got a safety wire that's keeping us inside the ring. Very little clearance, actually. So that's 60 miles an hour. Let's catch our breath. Yes?
Is it feasible to implement the de-icing process that happens on airplanes?
We've tried it before, and the Air Force has tried it, and just the force of the duration and amount of icing on the summit is really, yeah.
No, it's not feasible.
Definitely, yeah. So I mentioned that the heat of these pitot tubes is around 300 degrees, but even so, here's an event with 120 mile per hour winds. It's going to be a little bit louder. Our phrase is less ice, not ice less, especially when winds are this strong and it's that dangerous out. Just trying to knock off as much ice as you can. It really makes a difference. And safe and comfort. That has certainly happened to me in goggles as well. My rule is to buy cheaper gloves or goggles on Amazon so you don't get too emotionally distraught if you lose a $100 pair. So yeah, those are how crazy the winds can get and how we de-ice regardless of the conditions. So our observations are not only happening on, yes. Anyone have a question? Yeah.
Well, I just wondered, more of a technical question. Well, what kind of a heating system do you have?
It's just like resistance heating. There's
Just,
like coils and stuff.
specialized furnace or something?
Just electrical resistance. Yep, good question. So yeah, our observations are not only occurring on the summit proper itself. Here's, yes.
Do you have any problem with anybody getting frostbite with that? Most conditions, but take
It does not take very much, but we're well suited out. So Eastern Mountain Sports is our official sponsor, so they'll give us gear every winter. Some of their latest and greatest gear. Yeah. I'm knock on wood, I have yet to experience it. So we'll talk a little bit more about the observations beyond the summit. So I mentioned sort of in passing earlier our mesonet of stations. So here's an example of one here. It's got all the same instruments as we have on the summit. So we've got your anemometer up there measuring the wind, solar panels keeping them charged, our 2-meter temperature and relative humidity sensors, so how much moisture is in the air. And set it to relay actually all these observations in a data logger. So in case these can't actually relay to our website and show you that nice vertical temperature profile, we are still saving the data for a later time. We did have a weird case this last winter where it was cloudy for about 8 days down in the valley with light snow. That was up in northern New Hampshire. So it was actually cloudy long enough for our solar panels to start going off one by one. We were still able to actually record the data. We just weren't able to show it on our website in real time. So that was cool. Interesting, I will say. Maybe not cool, but here's the array of sensors throughout the White Mountains there. We've got some sensors down in Cannon Mountain, of course, Conway area, Mount Washington going up the auto road, Whitefield as well. And we are expanding our network. We did get a good bit of funding to expand the network into more parts of New Hampshire, more areas of the Whites, including also areas of Vermont and potentially New York State. So we're trying to cover more and more ground with our observations. So this map will change. So a lot of people might be asking, why even go up to the summit every other week and record these observations? And so there's a lot of value in these observations, mainly forecasting. So the rule of forecasting is the better your observations are, the better your forecast is going to be. Other ways people say there's garbage in, garbage out if you have bad observations. You can kind of think of us like a semi-permanent weather balloon up there. We're constantly collecting mid and upper level atmospheric data. So I like to call us the coffee-powered weather balloon up there. So of course, we're also recording wind speed and moisture. We're forecasting for precipitation events as well as fire weather. We're really good. We have a really good view of any kind of fires that might be starting up. Mountain hydrology, so the movement of water through mountainous terrain, hugely important for areas in northern New Hampshire like Conway and in larger towns like that. They've got really small watersheds. So if there's any kind of rainfall or snow melt, you get really quick responses from the rivers nearby. Again, we have over 90 years of climate data in an alpine zone, which is pretty much unparalleled, not only in the US, but the world. And And of course, we're able to report icing, really important for aircraft as well as turbulence. And then, yeah, we have tens of thousands of folks who visit us in the warm season, so we're giving them forecasts as well. So especially people who are the most vulnerable, like backpackers. There is an example of our higher summits forecast. This is a pretty crazy one. You can see here for the daily details. Let's see, northwest winds, 105 to 125, gusts up to 165, decreasing a little bit, 95 to 115 miles an hour, gusting only to 140, right? Mentioning wind chills as well. But yeah.
What date was that for?
This was for February of that event that I showed you with the haze chart a little earlier.
2023?
Yes. And so these types of forecasts, as a meteorologist, you dream of making forecasts like this. I would say the majority of them, unless you're forecasting for like a hurricane or something, you'll never even go close to this. So this is a really cool forecasting opportunity. It sort of racks our brains because we have less in the way of observations at our level on the mountain. So we have to go with a lot more skill and knowledge that has been accumulated by past observers in forecasting the weather on the summit. But giving people a heads up about this hopefully prevents hikers from going up to the summit during these dangerous conditions. And the hope is to, help save lives as, these sorts of heads up. Also doing a lot of different educational programs. So we have a lot of K through 12 programs, school day programs, after school programs, which are always kind of fun. It's when I get the most interesting questions from students. We do a lot of virtual programming, so we're able to remotely connect with any school in the country to teach them a little bit about weather and climate. We host a lot of field trips, which could be pretty fun. So here's one this last summer. We do teacher professional development. So if teachers are, if they struggle talking about weather data or data in general, they can come up and visit us. We usually do like an overnight program as well. We do school memberships with 6, 10, 15, and 30 hours of programming at the observatory. You can see 2 teachers here. These teachers got to ride along with us on our snow tractor going up the Otter Road, also called Arctic Wednesday. And then at the end of that, we actually zoom into their classroom and show them show their class that they're, in a pretty extreme place in the world, which would be pretty cool. We also do overnight edu trips, overnight climbing trips. We have our Science in the Mountain lecture series. Has anyone here ever attended one of those? Well, they're monthly educational series, and the topics range from things like climate change to extreme weather as well, really anything in between. We do have our memorial library. So we have a lot of other education resources, which I don't want to get too far into detail with, but we've tested a lot of unique products on the summit. We've tested tents. We've tested, of course, different snowpack sensors. Our core instruments, we're replacing these almost on a seasonal basis because we're testing so many, and we're going with the more accurate ones, the ones that are more durable as well. I would hate to be a pair of oboes boots on an observer's foot because we will trudge through any kind of crazy condition up there. So they're sort of our main sponsor. But I want to talk a little bit now about some of our current research. We've got a lot here. We have a weather station that was tested on the summit of Mount Washington, just below the peak of Mount Everest. This is the balcony station just below the actual peak. Again, it's a little pitot tube, and it doesn't move. It turns out the fewer moving parts there are, the less of a chance for something to break, which is especially important on Everest, where you can only get there for a couple of months out of the year. So that's been working out really well. There's an article in the National Geographic all about that. Looking at the rain on snow events and how those are increasing with time. Looking at how much liquid is in snow and how that might be changing over time. And we're also doing model verification. So we're seeing how accurate weather forecast models are. And then the University of New Hampshire has been monitoring cosmic radiation on the summit since the 50s. So that's pretty cool. I don't know too much about that work. I just know that they're looking at high energy particles coming from space, which is pretty awesome. On the note of research, I could talk a little bit about climate change on the summit of Mount Washington. So we have observed a warming trend, especially since the 2010s. It's now statistically significant, so it's above just like background noise or random chance. So this goes all the way back to 1934. And our average temperature has gone up to about 28 degrees, as I mentioned earlier, with the warmest couple of years happening in the last 10 or so years. So what does this mean on Mount Washington? Well, of course, warmer air. So we can see 3 different graphs here. We've got Mount Washington here in green. The interesting thing about Mount Washington is while we are warming, it's a little bit it's actually a lot slower than lower elevations, which I don't have an exact answer for that. It's an area of research that we're looking into at the moment. But we've got Hubbard Brook and Pinkham Notch here Those are all in the valley. Those sites are warming much more quickly than we are on the summit. What does this mean, though? Tangibly, warmer isn't that good? Well, yes and no. So spring is arriving earlier at all the elevations. So the length of the growing season has increased from less than 100 days on the summit to about 125 or so. And while that sounds really good, there's a lot of animals that require the seasonality of the changes, between winter and spring and things like that. And so if the timing's off even by a little bit, that presents really large problems for these animals and species that require, again, that temperature change here. And then, of course, we're losing the cold and snow, albeit more slowly on the summit. So we've got a number of days of frost per year, essentially days where it gets below freezing. So we've gone from about 238 or so down to a little over 220 days. And that it's been a bit more extreme further down in elevation here, between about 190 days all the way down to about 160 or so days in the modern era. Again, that's a change over about 90 years or so, which is fairly significant. We're also losing cold and snow. So this is the maximum snow depth in inches at Pinkham Notch and Hubbard Brook. You won't see it here for the summit of Mount Washington just because so much of that snow accumulates and then blows right off. So we don't have like a really long-term reliable record. There's been different methods to actually measure that snow. But our temperature record is certainly more straightforward. What's interesting about this chart is not only the decline in the maximum snowfall that's on the ground, but also, the winter of 1969 there. It wasn't only a snowy winter on the summit of Mount Washington, but equally snowy at Pinkham Notch. There's a really famous picture of one of the AMC hut crews standing on the roof and looking into the snow wall that surrounds the building. Got 169 inches or so on the ground at one given point, which is pretty insane. But this is not to say it doesn't snow anymore. It's just saying that the maximum snow depth has decreased considerably over time. So what do all these things mean on Mount Washington? One thing we can say for certain is that our winter thaw events are becoming more frequent and intense. We call them Swiss cheese winters now. So we'll still get the same amount of snow, but our snowpack may be interrupted by a thaw event, which may last a couple of days. And of course, those thaw events are accompanied by flooding in the lower elevations, and it's an ongoing area of research on the summit. So tying this all together, before I wrap things up here, if anyone's interested in getting involved, there's numerous ways to do so. You can go to mountwashington.org to become a member and support us, our work. There's various summit and valley volunteer programs. We have, of course, our annual Seek the Peak fundraiser. And not to plug things too much here, but I got this backpack for free for participating. So it's pretty cool. EMS backpack. Anyways, that aside, you can also, if you don't want to come all the way to the summit of Mount Washington, you can measure the weather on your own. You've got the COCO-ROS program, which is the Community Cooperative Rain, Hail, and Snow Measuring Network. Super long acronym. We love those in meteorology. And essentially, what that entails is, well, if you're an early riser, submitting a precipitation amount to the National Weather Service, and they'll give you a nice gauge and everything. We've got the Community Snow Observation Network. This is for the backcountry community, so just literally measuring the amount of snow on your ski trail or on your local mountain to give, again, scientific organizations a better sense as to how much snow is in these areas where we don't have direct measurements. With all that being said, I want to thank you all for your time this evening, and as promised, here's a picture of that glaze ice. So a lot less nice than the rime ice. But yeah, and that I want to open up to any questions.
In the past couple of years, there's been significant fires that have come either out west or from Canada. How does that type of air quality affect the measurements on Mount Washington?
Sure, yeah. It's a really good question. So it's mainly affected our visibility. So how far we can see. Last summer, it was very rare to get a visibility over 20 miles. We were constantly in that murky sort of fog. We don't have direct air measurement sites with the observatory. The State Department of Environmental Services has more of those direct measurements, but there have been field campaigns to do so. The issue with the summit of Mount Washington is that it's very busy. There's a lot of vehicles coming around, of course, the COG with the steam train and their emissions. So to get a long-term record of air quality would be really nice if we were on like a less busy peak. Yeah, overall, really just notably decreases in visibility, and also just like last season in particular, I got a lot of days where there was sort of like a campfire smell. It's like your eyes and nose might burn, stuff like that. So with that, we'll give hikers a heads up that the air quality might not be great on the summit. Hopefully I answered your question there. Just a little bit. Yes.
Yeah, the wind speed of 231. Could it have been higher than the machine not broken?
That's a very good question, and I think a topic of debate amongst the observatory. Yeah, it was just the de-icing. Yeah, that particular day was just so extreme that that anemometer was also heated on that day. But again, the conditions were just so extreme that it still iced over. Yeah, that's a good point.
This is a little off the subject, maybe, okay? But on the iPhone weather app, you know, comes with my iPhone, I keep a couple of cities. One on Amazon, that's right on the equator, and then cities my friends live. And I noticed there's a 159 Mount Washington Auto Road site that is right at your weather station. It's only if you like that app. Like you're down here and you want to know what's the weather up there, you'll drive or you look at it. Is that going to give you a good idea? Or would you rather just call somebody up and ask?
Yeah, no, really good question. So personally, I don't like weather apps. What they do is they take the average of a lot of data and then smooth it out, you know, both in the current observations and in the forecast. So for us in particular, we have the website mountwashington.org. If you do /current conditions, you'll be able to see like what the sensors exactly on the summit are saying. The weather apps for me, they simplify things that really shouldn't be simplified. So for example, you'll get like a cute little rain icon when in the background, what's driving that rain icon might be a chance for severe thunderstorms. And so I've seen people plan entire hiking trips or weddings, you know, on this little tiny icon on a phone. Not to necessarily make fun of it, but it's convenient, of course, but it's not always accurate.
So like that location is not specific to that. It's really taking a lot of information surrounding Earth. Like the location of Concord, New Hampshire.
That's right. Yeah. So for like Concord, it may take like the observation of like the airport, right? But that could be totally different from areas near the Merrimack River that could be quite a bit colder. So really, it's just smoothing things out that shouldn't necessarily be smoothed out.
Yeah, well, I know that those locations.
Yeah.
But it seems like the top of Mount Washington has location would be one location.
Yep.
It's not.
It's not. Yeah, I don't know. I don't know much about like their observation networks, like what exactly they're simulating. I just know that people who are doing that really don't recommend using weather apps for like hugely important decisions, just because there's a lot of smoothing that goes on yet. So you may be getting, you know, a station at the bottom of the mountain and then one at the top, and it's just taking like that average, which could be tens of degrees off. Yeah. Good question.
Who do you work for? Can I ask that? Who employs you to be a?
So it's Mount Washington Observatory.
It's private. Oh, it's the nonprofit.
It's the nonprofit. Yep. We get a little bit of, we get a tiny bit of funding. Like we're partly contract for the National Weather Service to get their data, but it's like $5 an observation. Like it's just, you know, they're just basically keeping us going, paying for our coffee. So we really do depend upon like grants and public outreach events. So our Seek the Peak is our biggest fundraiser each year. So, yeah.
How much of your day when you're up there is spent between working and relaxation? Do you have any time?
Super good question. So it's about a 12-hour shift, 6 a.m. to 6 p.m. So at night we'll go hiking if we want. We'll check out the sunset. We have to play Nintendo Switch as well. We've got a full like living quarters downstairs as well. So yeah, we spend probably like 5 hours or so at the end of the day, just kind of unwinding before we have to go to bed. But there are days like that video I showed with the 120-mile-an-hour winds where you'll sleep with the radio near the bed in case the night observer needs help. Yeah, so you're technically always on, but there are downtimes.
Two questions.
Yeah.
One's a quick one. Is it open for people to go for sunrise?
So the Sherman Adams building itself is closed, but you're definitely welcome to hike up. But it depends also. So the auto roads hours, I think usually after 9 a.m. So we have a lot of folks that come up and hike, and they'll, you know, kind of get upset at me where it's the state park that kind of runs the building. So they'll take out their frustration on me as to how they can't get like their chili in the morning or whatever they want to eat up there. So yeah, the hours are a bit more limited than you might think. Yeah.
And what kind of animal life do you see up there?
Sure. I see a lot of ravens up there. Very rarely will you see larger mammals. Typically, if you see like a moose on the summit, there's usually something going wrong with the moose. So it's just very little in the way of vegetation. But we have all sorts of species like weasels, We have a lot of rodents that visit us in the summit building itself, so that's why we have Nimbus. Nimbus also is the only permanent resident of the summit. He's our little gray short-haired cat. We have various species like Arctic hare. We can see like Arctic fox occasionally come up because Mount Washington itself is in a subarctic climate. It's like a tundra climate up there. The closest climate being Hudson Bay in Canada, if you wanted to make a direct comparison. So way up north. We got a slice of that in our backyard, which is really cool. Yes.
So you'd mentioned there was a monthly lecture series. Can you tell me more about that?
Yeah, so it's our Science of the Mountain series. So it covers topics like our current research, or there was one about the eclipse. Just really the topic will change each month. But if you go to our website, mountwashington.org, there's a lot.
Online?
Yep, it's online and it's free to register. Yeah. Yes.
You didn't mention anything about the jet stream. Is that what's above the troposphere?
That's right. Yeah, it's at the very upper limits of the troposphere, and that's what really drives the storms from west to east. Most of the time, occasionally we do get very rare instances where the jet stream will be partially reversed. So like we saw Hurricane Sandy back in 2012, the superstorm. It took a really unexpected track in the mid-Atlantic. Yeah. Any other questions? Yes.
I was just wondering if you could expand more on the cat.
Yeah, no, very cool. So Nimbus, no, it's a very solid question. So Nimbus has been with us for 3 years. He comes from Tulsa, Oklahoma. Previously we had Marty, who was a Maine Coon cat, but we've had cats essentially for the entire length of the observatory. The first 4 observers actually had a litter of kittens with them. But yeah, we've had cats, I think outside of maybe like.
You ever let them outside?
Yep. So Nimbus requires a very specific set of conditions. It needs to be above 45 degrees. It can't be too windy. It can't be too foggy. But he will go out in the alpine zone. It'll actually come in to do his business and then go back outside. So he's very mindful of the alpine zone, which we appreciate.
Other cats are rodent control?
They are, yes. And, entertainment. You had a question.
You talked a lot about how like it's really foggy and how that's basically like being inside a cloud. And is there any difference between like a regular cloud and like a storm cloud or a thunder cloud, like being inside of one?
Really good question. So we get what's called wet versus dry fog. So if we get like a really thin layer, like a veil on top of the summit, you won't actually get like liquid water deposition over everything. But if it's like a thunder cloud, it'll be dripping wet even though it hasn't rained. So it just depends on the amount of droplets in that cloud. Like the thinner clouds have less droplets and thicker clouds have more, which is really cool to see in person. Sort of gets all over your eyelashes and covers up your goggles. So it's a little less fun in that regard, but yeah. Yes.
I was just curious about how many times does the wind actually knock you off your feet?
Ooh.
And how far have you slid?
A couple of times, one of which was actually documented by the NBC Nightly News. So I had given them this great interview about like the record cold. And I gave them like 3-minute long, just like segment. And the only part they used was that very end where I was getting knocked off my feet. So that was 93 miles per hour in my defense. The other time was with Hurricane Lee last year. So it made landfall all the way out in eastern Canada. But on the summit, we had a gust to 106 miles per hour as I was carrying that giant precipitation can. So somewhere out there, there's footage of me like walking in just like slow motion in the wind, getting knocked over. So yeah. Yes.
Somebody just mentioned thunderstorms, brings up the question of lightning strikes.
Yeah.
Does your equipment ever get damaged from lightning?
We have had that happen, yes. So actually this last summer, our water system was affected by a direct lightning strike. So we had to reset that, or the state park folks did. So just to clarify, state park owns sort of the summit of Mount Washington. They act as our landlords, but they help us with a lot of different things. So without them, really, we wouldn't be able to do what we do. But yeah, summit strikes are scary. Kind of sounds like someone knocking over a trash can. But yeah, typically we'll stay down in the summit proper or in the Sherman Adams building. Nice and grounded there overall. But yeah, we do have occasionally damaging lightning strikes. Yeah. Yes.
Every now and then I'll go down a rabbit hole on the internet and find the list of the 10 most dangerous mountains to hike.
Yeah.
And Mount Washington is on several of them. I'm wondering if you have that opinion, and if that's how it's viewed up there. Before I ever went hiking in the White Mountains, my friend that was hiking a lot with me made me read Not Without Peril.
That's a great book, yeah.
And it
Scary book.
it put the fear of weather, huge respect for the weather
Yeah.
in me. Thank goodness.
So yeah, there's a couple of factors to answer your question. One has to do with the population in the area. So Mount Washington is relatively close to New York City, Boston, Portland, just really major population centers. So the folks at State Park call us an attractive nuisance because we just bring a lot of folks in from different regions who maybe are less familiar with the terrain. The other thing too is like a lot of hiking in New England, it's a little bit more tame, whereas the White Mountains really do represent like an area that's significantly above tree line, thousands of feet. And so in that case, the weather can change really quickly, even on a nice, relatively clear day in other areas. The problem with Mount Washington is it is exposed directly to what's called the free atmosphere. So just the free movement of air that's not affected by surface friction. So things could just ramp right up on a dime. So there was one day in particular, which I wish I included it in this presentation, but the winds went from 6 miles per hour to 164 miles per hour in 6 hours back in like April of 1993. So yeah, hopefully that answers your question a little bit. Yeah, so again, population being nearby and then just the changeability of the weather.
So on a practical note, where does your electricity come from? Your water?
Yep.
You have wells up there? Because I know there's lots of surface water there. And then, do you have porta potties? I mean, how does that all happen?
That's such a good question. So yeah, to answer them in order here, we've got electricity supplied by the town of Gorham. It actually goes up through the Cog Railway.
Oh, okay.
It's nice and sheltered in that way. But if the electricity down in the valley goes out, we've got 3 really large generators. I mean, you could probably fit 2 of them like lengthwise in this room. They're massive. For plumbing, we actually have a on-site like water treatment plant. So it's got all like the bioreactors, everything you'd see in a town level. And then for water, thankfully nice and separate from that process, we've got 3 separate wells that go down about 200 feet into the mountain. So pretty constant source of water. Another thing that's debated is the presence of permafrost on the summit. So to clarify that, Mount Washington's nickname is the rock pile because it literally is like geologically like a pile of rocks basically. So it'd be really hard for permafrost to form in those pockets. There have been studies done and there's been conflicting results, but I'd love for someone to bring them all together at some point. Yeah. Any other questions out there?
What is the observatory's thoughts of the hotel that might be built on Washington?
So the observatory, I think as a whole doesn't necessarily take a stance. I know there's been a lot of debate like the environmental impact. So generally, like personally for me, like I would not appreciate it just because I think it would affect our observations, especially having lights and things like that. But I don't know where that process is, and I'm sure it'll be a great discussion once it's more formalized, just amongst the partners up there. Yeah, good question. Yes. Yes, unfortunately, quite a few. No one in my team, actually, so none of the observers have ever perished due to weather conditions on the summit, which is remarkable. Typically, people who've gotten hypothermia, they come up, they're unprepared. They don't know a lot about the mountain and its climate. So actually, most of the hypothermia calls come in the early summer. So you may, have temperatures in the 80s and 70s down below, but on the summit, it's still upper 30s with that, dense wet fog and driving winds. So that's really kind of a recipe for hypothermia there. Any final questions or thoughts? All right. And if anyone has questions that they're not thinking of now, we'll come up with, my email is right there, ftarasiewicz@mountwashington.org, or education@mountwashington.org. But yeah, thank you all.
Right. Thank you so much, Francis. This was a wonderful presentation. We're really excited that you came tonight. Absolutely. So again, thank you all so much for joining us tonight. Next month's Superstellar Friday, we are going to hold in the planetarium, and it will be a screening of NASA's new feature-length documentary all about the OSIRIS-REx mission that brought samples back from an asteroid for the very first time. And then after that, we're going to have a Q&A with the director of that film as well. So we hope you can join us for that. That'll be a really fun time. Speaking of the planetarium,